Yeah, let's do this. Okay. Yeah. Great. So, welcome everybody. My name is Martin, and I have the pleasure to. I'm from BMW, and I have the pleasure to present our system on managing flaky tests. And we found a little nice title for that. It's a reference to an old Western movie that you all might know. And the reason why we chose this title is because our system is called Auto Sheriff. So we have a new sheriff in town to manage flaky tests. Before we jump into that system, I would like to give you a little overview of our system itself. So as you might know, we're developing cars. And specifically, my team is doing software quality for driving dynamics and autonomous driving software. So you all know autonomous driving software, and driving dynamics software is about basically how the car corners, which is also something very known, what BMW is very known for, right? When it comes to our development setup, we follow basic practices, which is we have a main line, and whenever a developer wants to make a change to that, they create a feature branch. And when we do that, CI starts running, and we have multiple stages of that. By the way, something I skipped over is like the overall size of our stack, to give you an estimate about driving dynamics on autonomous driving software, contains about 80 million lines of code. And we've got about 10,000 developers working on that, and about 600 changes being merged every day on this. So this, when we talk about CI, this is probably the most important metric here. Yeah, so the developer starts out, made their changes, they're happy with it. So they submit it, and the CI starts running. The first thing that runs is what we call the check pipeline. So this is classic pre-merge testing. Then they have to get a peer review, a PR review, and as soon as they pass all of that, we also have an optional step, which is pre-gate, which is something where we run on actual hardware, and this is something that we've ever want to do like after the approval of the reviewer, because otherwise we just don't have the capacity to run all. And then we have the merge pipeline. So this is something specific. Right now, but it has different words, different names in literature. So some people call it a merge queue, a submit queue. We call it the gate. And this is where PRs get speculatively stacked on top of each other in order to assert that although they might be passing individually, they might be conflicting. And in order to keep a green main line, we speculatively stack them on top of each other in order to test the exact state that is going to be on main line, but before we merge. And after that, we have post pipelines running and periodic pipelines. So those post pipelines are over resource intensive and flaky tests and periodic pipelines. So, and they still run on every PR, right? So this is important when we talk about culprit finding, for example. And then we have periodic pipelines for even more resource intensive stuff. So they run, I don't know, every 4 hours, every 24 hours. Yeah, let's talk about some numbers in CI. So we have about 11,000 pipeline runs. So each of that is a pipeline. And at max, we have about 40,000 vCPUs in use. And within 24 hours, we have roughly 1 million test executions. So this is a very specific view of our setup. And when we take a more abstract view at that, we can summarize those pipelines into pre-merge pipelines, which run in theory only on the feature branch. In practice, they run on a speculative rebase on the main line, but in summary, they run independently, right? Then we have the merge pipeline, which stacks them all together. It's a very critical point And then we have post-merge testing, which is non-blocking, right? So we have everything before merge is blocking and everything after is not blocking. And something to know is that a lot of PRs are waiting in this merge pipeline because you speculatively stack them on top of each other. And then if one fails, like you can discard all the other rounds, right? Because they get validated, because you cannot build on that one because you found it was something wrong with it, it was conflicting. So we all know that flakiness is a burden for developers, but we found that the impact actually differs between those pipelines. So we all know what flakiness looks like. It's like, oh, I submit a PR and the test fails on it, but all I really did was change the README file. So why is that failing? So I rerun it, it passes, and then I can merge. Yeah, pipeline dependent impact. So in the pre-merge pipelines, of course, this is a burden because I have to actively trigger reruns because otherwise I cannot proceed to further steps. But it's still only really bothering me. So it is, at that point, it is affecting a single developer, this flaky failure, because it's the one who is experiencing it in their PR. This gets worse in the merge pipeline, because if I have a flaky failure in the merge pipeline, it's not only my PR not being able to merge and being dequeued, it's also other PRs being slowed down, right? Because there was a failure and everyone who speculatively built on that can discard all their results. And then the merge pipeline window contracts because it detects some instability, and so it creates some burden also for other PRs, right? And then this is different in the post-merge pipeline, because here, this one is non-blocking, right? So flaky failure here does not automatically trigger, or it does not block me from merging, right? So it might be culprit finding, it's still bad, so this is not green, but it's different from the other pipelines. And with that in mind, we designed AutoSheriff. And the idea behind AutoSheriff is that we're going to detect flaky tests and move them from the pre-merge pipelines to the post-merge pipeline, because they do not create the same level of burden there. How do we do it? How do we detect flaky tests in the first place? So the original approach was to run a nightly pipeline and just run all tests, I don't know, 1,000 times, just on hand. And since this is all pre-merge testing, they have to be green. And if they're not green, if they're not passing, then they are somehow flaky. And this is how we use to detect flaky tests. And we also have a second heuristic in place, which is that we look at all the failures experienced in the merge pipeline within 24 hours, because conflicting changes are very rare. And so if you see a lot of failures of a test case in the merge pipeline, you're going to be suspicious of those being flaky failures. You still have to manually investigate to make sure that they were not actually valid failures, because there were conflicting changes. But if we see a test failing 2 times in the merge pipeline within 24 hours, we suspect it being flaky. We actually dropped the first one about 2 years ago, because we moved away from on-premise hardware to cloud providers. And when you do on-premise hardware, you have a lot of spare resources at night that are just lying around and waiting for you to be used for whatever experiments you want to run. But if you run on a cloud provider, you just pay for every run. So at that point, we could not justify those extensive rerunning anymore. And so we dropped this one. Now, in the course of that paper, we evaluated the effectiveness of AutoSheriff. And the way we did that is we looked at all the failures, all the test results from a certain period of time. And we looked at all the initial failures and we reran them with different strategies in order to see how clean our pre-merge pipelines are now that like AutoSheriff has been in place for several years. So among those initial failures, 6% were discovered as flaky by immediate rerun. So this is something that already the our build system is doing. So basically you can set an attribute flaky, which makes it rerun this. Oh, sorry, I did. Okay, no, you don't see it. Oh, sorry. Yeah, so you can set the attribute flaky and then you get immediate reruns. So 6% were discovered as flaky by immediate reruns, but this is the kind of flakiness that actually is caught, right? So this is not flakiness that really hurts us. The one that hurts us is the one that is still in there and it survived the immediate reruns. And yeah, here we go. And therefore we conducted additional reruns on top of those failures. And then we discovered that about 0.5% of all those failures were actually not regression failures, they were flaky failures. And given those statistics, I mean, it's always hard to judge on that if that is good or not, but at least for us, we found that those numbers have been very satisfactory to our developers. And we will conclude that AutoSheriff is very capable of finding failures. So right now we only look at the recall, right? So how well can AutoSheriff detect if it has flaky and then move it? But among all the changes that AutoSheriff suggests, so I have to say that moving a test from the pre-merge to the post-merge pipeline, that means you have to change code, right? And this is a PR that needs to get approved by someone. So we looked at all the PRs that were created by AutoSheriff, and actually only 18 out of those 55 that it proposed were eventually merged. So apparently the precision is pretty bad. So apparently those heuristics are not working very well. Working not very well in the sense that they do not have a high precision, but given like this number 55 is very much feasible for humans to review, right? So we looked at why those issues occurred and why the precision was so low. And one of the reviews was that flakiness was propagated through the merge pipeline. And the other one was that global errors could just inflate the failure count and just suggest to AutoSheriff that something might be flaky, although it's not. It is not really the test case, right? So the blaming was wrong at this end. We already talked about infrastructure issues, right? So in conclusion, I just present to you AutoSheriff our system for moving flaky tests from the pre-merge pipelines to the post-merge pipeline in order to relieve developers to some extent from the burden that flakiness is creating. Because the post-merge pipeline is not blocking. But due to that non-blocking nature, it also means that we need to actively monitor it in order to catch any regression that surfaces as a failure. And in order to do that, we develop, I think let's move over here to actually but it doesn't matter. So in order to do that, we developed a dashboard which we call CTRA, CI Test Result Analysis, which basically, given a job running in the post-merge pipeline, thank you very much, Oleg. So this displays all the tests running in the post-merge pipeline, and it basically starts by grouping those tests based on their estimated behavior. So we have those we look at those last 200 builds of the test case, then we group them based on that. So, and we group them into the categories of they seem to be passing, they seem to be freshly broken, freshly fixed, seem to be permanently broken, or they seem to be flaky. For every non-passing test, so of course we don't care about the passing one, so we don't really show them. For every passing test, we also display the test owner based on code ownership, as well as any existing issues that have already been created and that are linked to the test case. And least, but most importantly, we show the test result history of a test case. So again, post-submit for us means, post-merge means that we run those for every pull request. So every tile here is one pull request being merged and eventually triggered that test to be executed. The way to read this is top to bottom, left to right. And of course, the main task that you want to perform on this test result history is culprit finding, right? So you want to find the PR that broke the test case. And this is a very nice example where we can see that, well, it suggests, right, that this PR broke the test case. Retrieving this linear history in theory is very easy, right? Because you just have a Git history and you just sort your test executions along it. It was not so easy for us in practice because although we have a single basal workspace and we have a single CI that gathers all the incoming PRs, we do have different Git repositories. So our main repository is split into submodules, and therefore we do not have this one linear Git history, right? And therefore retrieving this plot was quite a challenge for us because if you sort those wrongly, for example, by the pipeline start time, you end up with a fuzzy edge. So what you can see here is that the blue PR, it actually got merged earlier, so it should be sorted here. But its pipeline started slightly later, right? And this happens when you have a lot of merges incoming at basically the same time. Another issue to consider is when you design post-merge pipelines, look at what version your CI system is actually checking out. Because for us, the default behavior of the CI system was that it just runs and it checks out latest head. And if you have only a few PRs being merged in an hour, of course that works. But if you have a lot of PRs being merged at the same time, then there's going to be another PR, might be another PR in between your PR being merged that you actually want to test and your pipeline starting. And so just checking out latest messages, just plain wrong, right? But it was the way our CI system was designed, and we had to add an additional pre-run step in order to restore the actual version of the system that we want to test. All right, so now we have this wonderful visualization, but that itself doesn't keep post-merge green unless there are people looking at it and acting on it. And therefore, we design a process which we call track and fix, which is mostly manual right now. We're working on automation, but we can talk on later a bit more. And this is basically people looking at the dashboard and getting active as soon as they discover a broken test. And in that case, they follow following steps. So first of all, they identify the author of the PR and the test owner. So those are the two parties that are going to be mainly involved in the following discussion. Then they trigger the tentative revert. So they create a PR that reverts that change. We do not have the full mandate to also merge that PR, but what we want to do is we want to trigger the post pipeline manually onto that in order to prove that this was the actual culprit and there was no like global errors going on or something like that that caused test failure. And that also helps us in the following discussion together with the PR offer. So then the PR offer gets notified and we request that they would please either revert the change, which is preferable, or fix forward and fix the test case. Now, if they do not respond within 3 days, we move on to the next escalation step. 3 days was chosen in such a way that despite holidays or despite weekends, you would usually have some time to just react, right? So this is not, you don't have to fully fix it in a time, but at least you have to react to the initial notification. And if we do not receive any response within 3 days, we escalate the issue to the test owner, because they should also have a very natural interest in the test being green long-term, right? And again, we await the same query, so please analyze the issue and fix it. And if they do not give us any response within 28 days, we will eventually delete the test case together with the feature. This is only the case, of course, for non-safety relevant test cases. So when we establish this process, when we activate this process for a given job, we first make sure that it is not, we determine whether or not it's running safety relevant test cases. And if it is, then we skip the last step. So there's another version which skips the last step. 28 days was chosen in such a way because we have a typical sprint duration of 14 days. So 28 days always gives you at least one planning meeting in between where you can ask for more capacity in order to deal with that issue. So in conclusion, I have the pleasure to present to you AutoSheriff, our system for moving Flaky tests from pre-merge pipelines to the post-merge pipeline in order to relieve developers of some of the burden that Flakiness is creating. And I showed to you Citra and Track and Fix, which are our systems for keeping the post-merge pipeline green. And before we come to the questions, I would like to give a quick shout out to all the people who were involved, or to some of the people who were involved in creating those systems, because actually, Maximilian, we just had the pleasure of presenting it, but of course, that system even predates us joining the company. So a quick shout out to Johannes Hummel, who was the PO involved in that and who created the initial checkout at the given timestamp mechanism that was essential for even running post-submit testing. Alex got the initial offer of AutoSheriff. Mikhail got the original offer of Citra, which started out as a side project. Stefan Jedon, who offered the flakiness heuristics in Citra. Daniel Merget, he contributed to the track and fix process, as well as our entire CI team. For example, Ting Lee, Alex Ulik, and Simon Rummer, thank you guys so much. I don't know if anyone's online or you're going to watch it later on. Yeah, we're really proud to present your work here today. Thank you very much.
Awesome stuff. I was wondering about the precision recall slide, because one possible explanation is maybe the precision recall was off. But I'm wondering if the different explanation could be, well, moving something from pre to post has a trade-off. The trade-off is maybe the people that rejected your PR were concerned that they wanted the early detection.
Yeah, excellent point. Thank you so much, because this is actually, I mean, it's a human decision, and we haven't really looked into the argument behind rejecting the PR. So we were only assuming that it would be wrongly classified, but excellent point. Thank you. Yeah, we should look into that.
So you're talking about the process to merge from to go from pre-merge to post-merge, right? So is there any process or tooling to do properly?
Yeah.
So otherwise the test will be shrinking, right?
Yeah, excellent point. No, there is no automated tooling. So this is something that the individual test owner would have to do on their own. So to merge to move them back. I mean, it has to be said that the reason why we do post-submit is not only flakiness, but also just resource consumption in general. But you're right. So when it only comes to flaky tasks, we should definitely also have systems to move them back. Yeah.
So do you have any data or how many times they are actually back?
Oh, yeah, good question. I do not know if how many times they got moved back. So no. Good point.
Hey, great presentation. So you had a slide a little bit earlier where you discussed how when a test is broken in post-merge, you will give the developer sort of 3 days. I'm curious if, you know, have you tried something like an auto rollback? And, you know, is there an organizational preference against auto rollback, or is there, you know, some sort of accuracy problem that's hard to do it on?
Yeah, excellent point. So it's also something that I learned just while creating the slides is that when it comes to the track and fix process, they got like a mandate from pretty high up management in order to do a lot of those things, so sending out those emails. And we do have auto rollback, but only for job breakages. So if the entire job breaks and no test gets executed, it's like all hands on deck, and we try to fix it as soon as possible, because of course we do not get any test signal. So if the test was broken during that time, yeah, we need to do bisect or stuff like that, right? So for like more critical issues, we do have not auto rollback, but we do have a mandate to do the reverts. And when it comes to test cases, it sometimes also depends on the branch, because on feature branches, on like mainline branch, you can do that, but when it comes to release branches, changing stuff is very critical and time critical sometimes, and they might prefer to just judge that the test was probably not, the test was wrong. For example, the test signal was wrong, or the feature is not relevant for this release or something like that. So this is one of the reasons why we do not have auto rollback, is because people might actually be like they might be merging that PR while being on a racetrack and just flashing it onto it, right? And they say, oh no, don't roll it back, right? Because I'm actually doing stuff here right now. So, right, yeah.
Great.
I do, well, you go first.
So auto rollback, there seems to be company pushback against that, but you do have feature deletion alongside test deletion. So how different is that?
Excellent point. Yeah, excellent point. The feature deletion, this is again something that we would only do on not on the release branches, probably, right? And we would only do that on mainline. Yeah, the deletion was also something that was like, I guess, a big discussion when it came to initially establishing the track and fix process, and the like the mandate that we got for that covered it. But it's a good point that like when you have the right to delete a test and a feature, you should have the right to, I guess it comes to like again the release branch and when you do it. So yeah.
Because the reason I say is, we've been trying to figure out how to reduce the burn, reduce the quantity of our disabled ignored tests, and the pushback for that has been just crazy from start. So I just imagine deleting a feature. I mean, like all hands on deck, things start early.
Yeah, I mean, this is only for permanently broken test cases. I don't have numbers on how many times we actually did that.
Okay.
So yeah, I would imagine that there's also a very senior developer involved in that process. So this is like not us just pressing a button and it's deleted, but it actually, if you look at it in a more detailed way, there's someone from like a senior architecture guy involved in that, and he approves it, right? And basically he has the mandate and it goes through him. So it's, yeah.
Thanks. Thank you.
Okay, so I had some questions about your rerun strategy for flake detection. So, because I'm just curious, like how this goes. So I guess my first question is, you go to, running on, some remote build execution service, and now it's like expensive to do your nightly N1000, which is like a lot of reruns. And so now you go to this other thing. Did you quantify what the impact is to accuracy when you did that?
No, so we would see, I guess the impact would be that the pre-mesh pipeline is more flaky now. I guess so I don't have numbers. I can only guess. Do we have numbers?
I don't know, we do. what we saw and like detecting the flakes in the rerun. So we don't have the exact numbers, but what we saw, like the flakes detected by the reruns were exactly the same flakes as detected by the heuristic. And therefore we then decided to just abandon the reruns.
Because I was also looking at your numbers and it looks like your current strategy is to essentially do rerun of 3. When you have a potential failure, you had that sort of mermaid diagram, I think that's what it's called.
Yeah.
Where it's like, okay, we do 1 rerun, then we do 2, and then we're done. So you had like 3 total executions.
Yeah, so this one was, so this is what is actually surfaced to the developers. So this is included, those reruns, those 3 reruns are included in the basal attribute Flaky, right? And this is it, because this is something we did additionally only for evaluation purposes. Yeah, basically our rerun strategy is if a test gets marked as Flaky, it's run up to 3 times, yeah.
Okay, so I did some numbers, and if you had, I think you had, what was it, like 10 million? Or 1 million test executions per day, you would expect like a flake rate of 10%, which is pretty high, like 10,000 misclassified test executions with this strategy.
You mean those?
Yeah, so
Yeah.
so no, it would be in fail-like. It'd be in the fail-like category. So you would expect in that category of your failures, you would expect that of that there would be like you know 10% is kind of high off like this, but like you're probably gonna have between like there's some percentage of those failures that are being misclassified because the test is too flaky or you're getting unlucky.
Just have to process that for a second. So
I know it's kind of weird because you have to do like, you know, probability multiplications in your head. So I mean, this is easier with easier with like a graph.
So this is, I mean, the eventual, like the flaky fails that survive the reruns are those. So this is 0.5%.
No, it's the flaky failures that survive the reruns because they fail 3 times consecutively, but it's not a true failure.
Yeah.
Yeah.
Yeah. So
that causes like developer problems because those failures go to the developers
yeah,
and then they'll have to deal with it and they'll probably just ignore it. But
yeah. But those are 0.5%, right? So
no, because they're in the fail category. They fail multiple times in a row, all 3 times.
so those are the ones that go to the developer. Those are the ones, the 6.2 is the one caught by the rerunning, so they will not be.
Right. Yeah, I was talking about the other category.
Yeah.
That one down.
So this entirely goes to developers, right?
Yeah.
And then we have 0.5% of those which are wrong signals.
Yeah, but I'm saying your 0.5 is probably like too low because you're.
Oh, sure. It's gonna be other stuff in here. Yeah.
Yeah.
This is true. It's true.
Because I was just trying to think like how, I was trying to get an estimate of how wrong it might be. Because like I understand the cost trade-off that is being made, but I was also trying to understand like how bad the cost trade-off is and whether or not like more needs to be done if you can afford it. Yeah.
Yeah. So I guess an intuitive step to improve our flakiness detection mechanisms when it comes to detecting flaky tests would be to do nightly reruns, but not every test case, but only the exact failures that happen in the day. I believe you're doing that, right?
Yeah, we do that.
Yeah, and that would be, I mean, this is what we did for evaluation purposes here. And that should be like fairly inexpensive, right? And it's really just an engineering effort that would need to be done because we have this like oh, we need to check out at a timestamp and not at a SHA because, yeah, we have all those records. Yeah, right. And just reproducing a bill is unfortunately, not straightforward.
Thank you very much. Sorry, these are just like math thoughts.
No, please. I hope I roughly got it.
How do you do batching? Like, so sorry, in one of the graphs you were mentioning, detecting a flake. So how do you batch and find the culprit? How do you find the culprit when you found in your Citra?
Batching in terms of like what Maxi presented yesterday in terms of PR batch.
Well, but even go to sorry, next
Forward or back?
back.
This one.
I guess there's no one back. Okay, so you evaluate something as failing in your system. You alert the developers, you alert the test owners for this. Wait, is batching involved in this at all, or am I?
Oh, PR batching?
Yeah.
Like testing multiple PRs
Yes.
at once? Oh, not in the Postmark part.
Not in the Prosper.
Yeah. So every PR gets tested individually in post-merge, and this is why we don't need bisect.
Okay.
Yeah. Any further questions? Yes, please.
Can you talk more about the strategy for the actual, you said code changes to move flakiness from processing to post processing? Just like how you go about doing that, has that been tuned at all? Any additional, does that increase the flakiness if it gets moved to post processing?
Oh.
And what logic changes, I guess, would taking place there when you push it?
So internally how this is implemented is fairly simple. It's just we add a a tag to the target, to the basal target, and the pre-merge pipelines exclude the tag and the post-merge pipelines include the tag. So, and apart from that, the setup of those jobs is pretty much the same. So I would expect that them running in a different pipeline does not impact the test itself at all, apart from like they are being built together with other test cases, with other flaky test cases. And then like depending on how well isolated the basal run is, like there might be an impact. Yeah. All right, thank you guys so much for this great discussion. Since we have 5 more minutes.